modeling multiplication of two-digit numbers. The learning goal for you is that I can use base 10 block rectangles to model the multiplication of two-digit numbers. Let's start off by looking at an example. There are 14 buses that will transport students to the National Indigenous Peoples Day celebration. Each bus has seats for 52 students. We're to estimate how many students can go to the celebration, and then show how we estimated it. So my approach is to start off and look at the two numbers that we're going to be dealing with, 14 and 52. 14 is pretty close to 15, and 15 is an easier number to work with, and 52 is fairly close to 50. So those are the two numbers I'm going to start with. If I'm looking to estimate the total number of students, I'm really looking at a multiplication situation, because I've got 14 buses, or in this case I'm estimating as 15, that are full of approximately 50 students. To make that a little bit easier to multiply, I know that that's the same as saying 10 plus 5, which is the 15, times 50. And the 50, of course, can also be broken down to be 5 times 10. So if I'm going to multiply that out, that's the same as saying 10 times 5, and then 5 times 5, added together and then multiplied by 10. So that tells me that I've got 50 plus 25, and I'm going to multiply all of that times 10, which means I've got 75 times 10, which is approximately 750. So I've estimated that I've got about 750 students on those buses. Now, if I wanted to use a model to do the same estimation, this time I'm going to be a little more precise. So as I've got a model of a 14 by 52 area, and I'm using hundreds, tens, and ones blocks. So the grid that you're seeing in the background here, those are each one of those boxes is considered a 1. So when we look at this area here, for example, that is 10 by 10, which is, of course, 100. So if you look at this, that is 10. Then the last half here is another 4. Across the top, I have 5 groups of 10, and then an additional 2. So you can see that we've got 14 over on the side and 52 across the top. We're asked to explain how our model represents 14 by 52, and that's essentially what I've just done there. So all the blocks in my model make up the area of a rectangle that is 14 wide by 52 long. To calculate its area, I multiply 14 by 52. Now we're asked to use the model, which I've reproduced here again, to do our multiplication. So as I've said, each of these squares at the top are 10 by 10, so that each of them gives us 100. And then in the bottom section here, each one of these blocks is 4 by 10. So each one of those is going to be 40. On the side, these are also 10 high, and they're only 2 wide, so that gives us an additional 20. And that leaves us with just the ones across the bottom here, and we have 8 of those. Now we just need to total up everything that's in the drawing. So we've got 1, 2, 3, 4, 5 times 500s, so that's 5 times 100. And similarly, I've got 5 40s across the bottom. Then I've got, I said 20 on the side, and then 8 ones. All I have to do now is total those up. I've got 500 plus 200 plus 20 plus 8, which gives me a total of 728. My initial estimate was 750, and I ended up with a total of 728 when I did the actual calculations. So my estimate wasn't far off. We've got another problem now that says, create a problem that could be solved by multiplying two two-digit numbers and do not use any zeros in the factors. So the example that I created here were that there are 23 kids in my class, and each brought 25 cents for charity. How much money was brought in altogether? So that's my problem that I've created. The next thing I'm asked to do is to answer the question is, how do I know that it's a multiplication problem? Well, in this case, it's like having 23 equal groups of 25 cents. which is 23 times 25. So anytime you're talking about groups of things, typically you're going to be talking about multiplication. Now we're asked to estimate our total. So this one maybe not necessarily quite as easy as the last one, but I'm going to do a similar estimation. So I'm going to look and I'm going to say, well, 23 times 25 is pretty close to 20 times 25 because I'm confident that I know how to do that. That's the same as saying it's like 2 times 10, which gives me 20, times 25. Or I can change the order of that to say 2 times 25 times 10. The 2 times 25 is easy to say, well, that's just like having 2 quarters, which is 50, and then I'm going to multiply by 10, and that's going to give me 500. So that's an estimate. I know it's going to be a little bit low because I multiplied by 20 instead of 23, so my number is going to be a little bit bigger than that. The next thing we're asked to do is to model the multiplication as a rectangle. The objective here is to use as many hundreds and as few ones as you can to build a rectangle, and then arrange the blocks so that the hundreds are together and the ones are together. And we've done this in advance so that you can see that what we've got here. Each of these blocks is 10, 10, 10 high as well. And then on the end here we have this section here is 5. And going down this way, you can see we've got 3. So we've got a total of 23 on the side and 25 across the top. So that's what we're looking to accomplish in our equation. We're asked to use our model to calculate the area, which is 23 by 25. So we identified this as being 23 across the top here. So we've got 10 by 10 block here, which is 100, another 100, 100, and 100. Then here we have 5 rows by 10, so it's 5 by 10. Same thing here, another 5 by 10. And down here we've got, so we have 10 by 10 and 3. So across the top we've got the 25, and here we've got the 23. In this bottom block we have 3 times 10, which is 30. Another block of 3 times 10, another 30. And then what's left over here is 5 times 3, which is 15. We can now add everything up. So we've got 4 times 100, 400 blocks. Then we've got these 2 blocks, which are both 50 each, 5 times 10. So we've got 2 times 50 blocks. Across the bottom we have, that's a bracket, 2 times 30. And then plus the final 15. So that's 400, plus another 100, plus 60, plus 15, which is equal 575. The next question says to check your answer against your estimate, and asks, does your answer seem reasonable? Well, our initial estimate was 500 because we had done 20 times 25. And we see that our final answer was 575. So getting 575 when we had estimated that our number was going to be around 500 certainly reinforces that our number is in the right range. Now they ask us, why do you multiply to figure out the total number of students? And because we're told that the total is going to be 14 equal groups of 52, in those circumstances when we have groups of something, we're going to be multiplying them together. The next question is, why do we estimate the total number, or why is estimating a good idea? And the answer is fairly simple, that by estimating it helps us to make sure that the answer we're getting makes sense. So when I got a number of 565, knowing that I had estimated it to be about 500 gave me some confidence to say I've probably done my calculations correctly, because I'm getting a number that's pretty close to what I estimated. How were you able to solve a problem about 14 buses with 52 students in each using the rectangle model? Well, fairly simply, this is another equal groups type of problem. So you've got 14 buses with an equal number of students, 52, in each bus. You know that you can solve those by multiplying 14 times 52. So I could have made 14 groups of 52 ones. But I know that if you multiply the length and width of a rectangle, you get its area. So I created a rectangle with a width of 14 and a length of 52, and I used the blocks to figure out the area. Its area was the product of 14 times 52. Now, one key thing here is to figure out how you can predict the number of hundreds blocks needed for your rectangle. You use the number of tens in the factors to figure out how many hundreds blocks you need. So in our example, we've got 14 times 52. We're looking at the 1 and the 5. So that tells us that for our hundreds model, we're going to have a block of 10 by 10s that are 1 10 wide and 5 10s long. Multiplied together, that's 500 blocks. How about predicting the number of ones you could use? You use the number of ones in the factors to determine the number of ones blocks you're going to need in your model. So a similar approach, we look at the first factor, we take the 4 times the 2, that's giving us 8, so that we know we've got a block that's 4 by 2 of ones. Let's take it sort of up to a higher level now and say, how many parts does each rectangle have? Well, we can say that there are actually 4 parts. There are the hundreds blocks, which are right here. Those are the 10 by 10 blocks. Then there are the ones blocks. Those are down here. That's the 2 by 4 block. Then there are the vertical tens blocks here. And then finally the horizontal tens blocks at the bottom. How does the number of parts relate to how the length and width of the rectangle were broken up? For the 14 by 52 rectangle, we can see that the length was broken up into 5 tens, so across here is the 5 tens, and then 2 ones. The width was broken up into 1 10 here, and 4 ones. So you end up with 4 parts altogether. You've got the hundreds block, the ones block, the vertical tens block, and the horizontal tens block. Lesson summary. You can model the product of two two-digit numbers by arranging base 10 blocks into a rectangle. Here's an example of 24 by 31. The length and width of the rectangle are said to be the factors. The rectangle is 24 wide and 31 long. The model uses as many hundreds blocks and as few ones blocks as possible to build the rectangle. So we're trying to keep this number of ones to be as small as possible, and the number of tens blocks up here to be as large as possible. The hundreds blocks are together, so we put those all together, and the ones blocks are also kept together. And then the tens blocks are in separate parts. The area is the product of 24 times 31, which if we crunch that out, 24 times 31 means we've got 6 blocks of hundreds, as we've seen here. 1, 2, 3, 4, 5, 6. 12 tens. Remember, there are 4 rows here. So there's 4 rows of 10 blocks together. And then we have 3 sets of those. 1, 2, 3 sets. So that gives us 12 tens. And then there's another set of 10 here. And another set of 10 below it. So that's the 2 more tens that we see here. And then finally, there are 4 ones in the bottom corner. Adding that all together, we've got 600 plus 120 plus 20 plus 4, which gives us a total of 744. You can predict the number of hundreds and ones blocks in a model by looking at the factors. For example, in the base 10 block model of 24 by 31, the number of hundreds blocks comes from multiplying the tens. So we're taking the 20 times the 30. When we multiply those together, we have 600 or 600s. The number of ones comes from multiplying the ones. Here we've got 4 times 1, so that tells us we've got 4 times 1, which is 4, or 4 ones. The number of horizontal tens blocks comes from multiplying 4 times 3, so that's the 4 times the 3. The number of vertical tens blocks comes from multiplying the 2 times the 1. You can sketch the model in either of the ways shown below. These are sketches, so the proportions of the rectangles don't have to be exact. Either way, you're getting the same representation. I find it's easiest to work with this second form because you're not dealing with as many small boxes, and it just seems more logical for me to take this number and break it up into two pieces. Similarly, taking the 24 and breaking it up into two pieces. So that's the version that works best for me, but you use whichever of the forms you find is easiest to understand. Some key terms to remember. Area. It's the amount of space in a two-dimensional shape. The number of two-dimensional units that can cover a space, for example, a rectangle that is 2 units by 3 units, has an area of 6 square units. Factor. A factor is one of the numbers you multiply in a multiplication equation. For example, in 2 times 5 equals 10, 2 and 5 are both factors. Product is the result of multiplying. For example, in 3 times 4 equals 12, 12 is the product. Now it's your turn to try some of the questions.